The voltage that we get from our wall socket is called alternating current. In plain terms, alternating current means that the electricity will flow in one direction through a circuit, and then it will reverse direction and go the opposite way. It's important to remember that when a line goes up in the pocket scope, there is an increase in voltage, and when it goes down, the voltage decreases. Another interesting observation is that the pocket scope has a positive and negative range. When the graph is in the positive side, meaning this zone, the electricity is flowing in on one direction. When it is in the negative, in this zone, the current is flowing in the opposite direction. This cycle occurs 50 times per second, and it is important to notice that it is a gradual increase and decrease of voltage. 50 times per second might sound fast, but in electronics terms, it's actually very slow. As you can see, this slider here is labeled frequency, and we can use this slider to adjust the frequency of the alternating current. I would like to expand on the knowledge we gathered in the previous lesson and illustrate this concept of alternating current to you in a practical way. We'll do this by connecting the two wires coming out of the transformer to the two contact points on this small light bulb, as well as this DC motor. Firstly, let's do the visual connections for the light bulb to make it clear what we're doing, and then we'll do the actual connections in the connections window. Here you can see we have wires running from the transformer to the light bulb. The electricity is going to flow through this path, through the light bulb, down these wires, and back to the wall socket. Then it's going to reverse the direction, again through the light bulb, up these wires, and end up at the wall socket again. Okay, let me clear this drawing and let's connect these devices in the connections window. It's actually quite simple. All we have to do is connect the wall outlet to the transformer input and the transformer output to the light bulb. Here we can see a very nice visual example of alternating current in action. I'm going to slow the frequency way down, and let's compare the light coming from the light bulb with the curve of the pocket scope. I think it's quite apparent that there is light energy when these voltage lines go up, but importantly also when they go down into this negative range. If you watch carefully, you will notice that the light bulb is dead when the scope is in the middle or 0 volts. If I crank up this frequency slider, you'll notice that we get close to a consistent light. This is because the switching is so fast that the bulb does not have enough time to lose the heat energy, and to the naked eye, it looks like a consistent light source. We have now proven that alternating current is acceptable when providing power for the light bulb. Let's quickly connect the DC motor to the transformer. Leave the transformer connected to the light bulb, and let me connect the DC motor as well. Can you see how the motor is now turning in both directions? Although this is another nice example of alternating current in action, this is obviously not what we want. In the next lesson, we'll start the process of turning this alternating current into direct current, and thus make the motor turn in one direction.